I would like to thank again all the speakers, and in particular Jeff Sawyers for having organized this workshop. And see you tomorrow morning at 8:30.
1, 2.
How are you? This is Big Data, Big EO.
Keynote, we have 4 out of 4 panel members. We have an audience.
Should we get going? Okay, afternoon everybody. Still a few free seats in the middle, so please continue to make your way in so we can get this Big Data, Big EO session kicked off. So I'd like to welcome you all here on behalf of Adam and I, who are going to guide you through this afternoon's session. The session is very much focused on exploring the key challenges around access and distribution of global Earth observations data sets, and particularly the role that kind of the international community has to play in that. And this is a meaty topic, and luckily, unfortunately, we have a great panel lined up to help contribute to this. So very much look forward to it. I want to encourage participation from yourselves in today's session. So there is a Slido set up, and the code for the Slido is 8172, and we'll also be tweeting through the event. So please get involved and contribute as much as you can.
Thanks, Dan. As you know, Dan Wicks is from the UK Catapult Space Applications, or Space Applications Catapult, one of the two. I'm Adam Lewis from Geoscience Australia, currently heading up Digital Earth Africa implementation team. Before we kick off, I just want to spend 2 seconds showing you something about big data. So here's a nice picture of Africa, which didn't exist 24 hours ago. So 24 hours ago, someone called Kirill, one of our bright programmers, started a process running on some provisional data that the USGS had produced, crunched 30,000 traditional Landsat scenes through a process that calculates the average of those scenes for 1 year, took 24 hours on 4 Amazon spot things, whatever they may be, cost the grand total of $80 or big dollars as we call them in Australia, and we suddenly have a continental product covering 30 million square kilometres, 4 times the area of Australia, that never existed before. So big data is real. It opens real opportunities to do things fundamentally differently and in much more informative ways than in the past. What we have here today is a keynote speaker, who I'll introduce in a moment, and a panel of 4 people, and a willing audience. And It's great to see so many people turned out. My colleague, Andrea Sekira, who's organised all this, will whip you into line if necessary and try and keep me and Dan on track. If you go to sleep, I'm going to target you. I know enough people in the audience to be able to point a finger and ask for your opinion on things. Other than that, we'll try to behave. Right, so we now go into our keynote presentation, which is going to be by someone whom you all know well, Dr. Gilberto Camara, who is the director of the Secretariat of GEO, which he's been doing since July 2018. He's extremely well known in the Earth observation community for his leadership in geoinformatics and geographical information science. But he was also the leadership in Brazil, in INPE, when they actually pioneered open data. They were the first place in the globe to say all the data for Brazil is freely shared. So they've been at the forefront of open data and big data. And I remember going to Landsat meetings and hearing how Brazil had big optical fibre pipes moving data around when we were moving data in Australia in the post. So we should note their leadership and his leadership over a long period of time in this space. Gilberto has been involved in GEO since its early days and led the Brazilian delegations that helped initiate GEO and GEOS. So, Gilberto, please come to the stage. You have 10 minutes, and Andrea to fear if you go over.
I may use a little bit more, so 15. Okay, good morning, and my first words are of thanks to the fantastic Australian stewards here, Adam and all the team, for organizing such a magnificent conference. And also, is there anyone from South Africa here for me to, you know, it was a great game, Springboks, but congratulations. England never had a chance. Now, could you, Andrea is taking care. So today I'm going to speak less as a Secretariat Director and more, to something I feel much more comfortable as a researcher who has had lots of experience. So I'm gonna put some reflections here. I'm assuming that we all like analysis-ready data. We want it, and I'm assuming that that's a given. So the question that I've tried to address is, what are we going to do with it? So we're going to discuss how to generate it, but I'm going to go a little bit further. What do we do with the analysis-ready data, and how is it used? So I'm going to address very quickly some points that we will need to consider in this community to move this analysis-ready data and this effort, which is very important and which Australia is taking an important road forward. So just some reflections. I think everybody here in this room agrees with the zero download model. So no downloads. We hope that the space agencies will open the data, produce analysis-ready data, which will be in cloud platforms. We're going to have software to analyze these on the platforms. We get the results, the users are empowered, we get a better understanding for sustainable development goals. Now, we are in the situation of flux in terms of the technologies that we're putting together. There's a lot of flux going on. These are only some of these. This is not comprehensive, but you look at it, there is things there is a filter box from CNES, there is the Open Data Cube from Australia and now CEOs, there's Code and Art, there's things from Google, Descartes Lab. So we're looking at really one of the troubles that people have at Amazon Web Services and so on. So it's a fragmented landscape. Now, what has happened in the past can guide us a little bit, can guide us because we know that this is not the first time that a fragmented landscape has appeared on the world of information technology. One example, just to go a little bit on the 70s and 80s, was the UNIX Wars. So there was a time, you might, I'm old enough to remember this, there was the Solaris from Sun, AIX from IBM, Ultrix, UNIXware, SCO, and now there's no longer. Everybody uses Linux. There was a time there were lots of open source GIS competing for the attention, for your attention, and now it's gone. Everybody uses quantum GIS. So there was this convergence of technologies that happened. So one could wonder what is going to happen on our world. Well, there are three scenarios. The scenario which I consider to be more unlikely is the continued fragmentation. This is not the tendency in Earth observations because it's in IT, normally there is a concentration. Whether this concentration will be led by commercial concentration or will be concerted by groups like COs or NGO, this is still open to question. I still think there will be a concentration. It's not likely that everything that exists now will survive in 5 years' time. So there is a convergence of platforms, which I hope will happen. And for that convergence to take place, we need an effort that goes beyond the analysis-ready data, is what do we need to put together? And I'm not going to give you any recipes. I'm just going to say there are traditionally two ways around it. One is a standardized API, like POSIX was for Linux, SQL was for the databases, or a de facto common API like GDAO is for many of those who use raster image processing. And the ecosystems that will be developed there are mostly ecosystems, at least from my perspective, mostly open source and either Python or R or a combination of the two. I'm just not proposing any solutions. I'm just saying that the convergence will happen in some way or another. Now, the other thing is there are lots of data. So we have been lucky to have a good agreement in G with Amazon. You know that we have issued $1.5 million in credits. There will be similar announcements this week in other providers. There's lots of data there. And some of this data is analysis ready, some it is not, but let's suppose all of the data there will be analysis ready and will be on different clouds. I'm just using Amazon as an example. So after we do the analysis ready data, then we need to agree on some definitions. We need to agree on a definition what a catalog is. We need to agree on a definition what a collection is. We need to agree on definition what a data cube is. You say, well, this is obvious. No, this is not obvious. There's no agreed definition. People use different definitions. And this is which is not good for the community because different definitions lead to incompatible implementations. So, for example, there's an ongoing debate right now, and it's really ongoing, whether the OGC has put out a document for comment from the data cubes. And some of us has responded to these comments in a way very disagreeing with what the OGC is doing. I'm not preempting what's going to happen. I'm just telling that community, please get together and work with the OGC, because what comes out as a standard needs to be reflecting what we think. So for the interest of time, I can send you later. I've been working together with some friends from academia, Marius Appel and Edza Pebersma, in a definition of a data cube. I'm not going to go in much details. I don't have the time for that. But you need a definition for a data cube, because that's the way, if you're going to produce the analysis-ready data, and then you say, I'm going to put it in the data cube. And then the question is, you have defined what analysis-ready data is because CEOs has defined a CARDAO standard. But what is a data cube then? We need to agree on that. We need to agree on data cube is, how it was, how it operates. And we need to learn. Okay? Beautiful things is once the analysis-ready data is on a data cube, then the fun starts. Then there's a lot of fun. Fun being we enter a completely new world that is new for most of us. We are accustomed to looking at images. We are accustomed to looking at images and understanding objects in images. Now, when you have 500 images, you can no longer look at 500 images, 520. For example, if you take the whole MODIS archive, you have for each point on Earth the 16 mode 13 Q1. You have probably up to now about 500-something images. You cannot look at the whole MODIS archive one image by one image. It doesn't work. You need to look at the time series. And then we need to understand what a time series is and what makes a time series from Earth observation different from a time series of financial or a time series of prices of oil. What's the difference? And then what are the technical methods for dealing with this? It's fantastic, but it's a challenge as well. So you can say, okay, I can look at, one can look, if I guide you to the time series, you can see, for example, that the first time is something that goes back and forth during the year twice, but this is agriculture. This is NDVI agriculture. Humans can see it. And this one is something that changes a little bit because of noise, but keeps more or less to the same high level. This is a forest. But the other third is the more interesting one. It's a place that was, a forest has existed there from 2004. It then was cut, developed a pasture, then it went into agriculture. This is the tough one, but that's the one you're interested in. You're not interested in the say, okay, in agriculture, you're always interested in it. But if you understand the change, you need to be able to decode these things. It's anything but easy. But the end result is what we call land use trajectory, which are the transformation of land cover due to actions of land use. So, again, I'm not going to bore you with these details, but they exist and they are important. What is this? The fact that now we have time series explicitly comes up with the challenge of understanding how to treat them mathematically and how to build a multidimensional space where you can run algorithms. It's a challenge. It's important, different ways to look at it. What in the end you want is to be able to describe patterns. So this is a forest, and these are bands. So NDVI, EVI, near infrared, middle infrared. This is forest, this is cerrado, this is pasture, this is soy corn. And this is non-trivial. Look at pasture and cerrado. They both look, these are shallow vegetation, small vegetation, but they're completely different. There are land services. As I speak, I'm not going to name them, but there is an operational global land service running currently, which does not make this difference. So when I look at this data from for my country in Amazonia, I do not know where is the natural vegetation which always existed there and where that natural vegetator has been removed to put the cows. So I cannot do public policy with that data because I don't know what's the impact of human actions. So you need to be able to separate, even though it looks tough, and it is, natural shrublands with pasture that comes from grasslands that you come from Africa and planted in Brazil. Extremely important from the point of view of policy. So to finish up my short time, I will tell you that data cubes are born different. But the message I wanted to give to you is that we need to deal with the differences. So Google Earth Engine is some way, Open Data Cube is another way, we have been developing Brazil, it's third way. They're all different. So how can we work together so that we work closely? First, we need to learn from what Google Earth Engine, I'm going to jump this part, I'm just going to say everybody who works with analysis-ready data and data cubes need to master Google Earth Engine, if only to understand what they have done. And, of course, I would argue that anyone who works at South nowadays needs to understand how the Open Data Cube from Australia works. That's what it does, what it doesn't do, where one can contribute. It's going to be a very important platform for the future. It is already a very important platform, and one needs to, but one needs to understand it doesn't come easy, it doesn't come obvious. It's not something that you look at it, it tells you what it's going to do. You need to do some work. So to sum up the point, my final point is that data cubes are not created equal. And data cubes are the place where you put your analysis-ready data. So Google calls things differently from the ODC, and there are others that call, the point here is there are different implementations. They have a right to exist. They have good reasons why they're different. Okay, and how do we deal with them? We need to, I don't think we're going to have a complete unique API, but we need to develop services, web services, that can at least make us aware that they exist. So if you have an open data cube running somewhere in Amazon or Huawei, whoever cloud, that data cube must be able to tell you what it's inside that. So I'm here, I have this, so many data. I have, this data comes from Landsat. It is being processed by Australia. It covers this time lag. It covers this space area. There's no standard for that nowadays. We need to create one. So I've been toying with the idea of like things, for example, web data cube services. That's something I do in my spare time, is how to design a way, I call it EU cubes, but basically what would be the contents of a standard that would be used by Google, by Open Data Cube, by whoever, to describe itself. What are the collections you have? Describe yourself. If I need to get a data cube, what are the files that make up that data cube? If I just want to get a time series, what do I do? This is a challenge. So there are many, many challenges, and I think I just wanted to highlight in the time that I have available that analysis-ready data is an important starting point for a big world out there. And this big world out there requires both the convergence of some sort of standards that we are at least able to share what they do, and we require a complete, and I emphasize complete, retraining and rethinking of the way we do extracting information from imagery. The examples that you already have shown from the Open Data Cube show the power of change, the power of imagery, but of course, it's only a beginning. So the community needs to rethink, needs to learn statistics, needs to learn advanced machine learning. They need to do that. And they also need to do something I emphasize, share the data. But this is a topic for another presentation that I'll do tomorrow. For the moment, I just want to commend the leaders in Australia, commend the leadership of Australia and CEOs for the work they're doing, and wish you good work there. Thank you very much.
Thank you, Gilberto. Thought-provoking as always and authoritative as always. I just want to, before handing over to Dan, who will introduce our panelists, reflect on a couple of elements of that talk. One is that we live in an ecosystem of capabilities. The next is that that ecosystem is necessarily evolving and will keep evolving. It's also the ecosystem which enables us to have fun, which is the funnest word in Gilberto's talk. And that fun takes the form of extracting new information from these data sets. How do we keep having fun as the ecosystem evolves? If our bit of the ecosystem dies and some other part takes over, how do I stop that having me having fun? How do I keep having fun in that context? If my analysis-ready data stream dries up or transforms, am I in trouble?
Thanks, Adam. And I think to reiterate another point Gilberto made there is how do we keep doing that whilst bearing in mind the user and their ability to navigate this fragmented landscape and really enable them to start using these tools in a meaningful way. So now it's time to invite our panelists to come and take a seat, who will help share some thoughts around this topic and evolve the discussion. Firstly, we have Joe Flasher from Amazon Web Services. He's the Open Geospatial Data Lead, helping organizations make the most effective use of data in the cloud. Dr. Brian Kielau, with NASA, 32 years at NASA, currently leading CEOS's Systems Engineering Office, which supports CEOS in a number of initiatives. Dr. Virginia Burkett from USGS, who's the Chief Scientist for Climate and Land Use Change. She is the chair of the US Global Change Research Program as well. And finally, Dr. Astrid Koch, who's a senior expert in the European Commission. She's working on the international dimension of Copernicus. So a real varied spread of knowledge and expertise there. And I welcome Joe to open with some initial remarks.
Yeah, we have a microphone, or should I just speak loudly? Cool, thank you. All right, hello everyone. Thank you for having me here. So I think what I would like to maybe start. Sure. Yep. Sure. I don't have any slides, but I need to stay out of the light, I guess. All right.
We've got a gender balance panel, but it's also really people stand up programs. They can fall asleep.
Okay. I might be the one falling asleep, so apologies for that. Yeah, so I wanted to start off by just sort of maybe explaining why Amazon is here. Hopefully, a number of you know of us because you might buy things from Amazon.com. But you might be thinking, why are we here at an event like Geo, right? And that's a fair question, and there's a couple reasons why we're here. So I think the first one was sort of illustrated when Adam spoke in the very beginning. If you saw his Africa example, the imagery over Africa. I specifically work for Amazon Web Services, so that's the cloud computing part of Amazon, and we're an infrastructure provider. So in Adam's example that he gave earlier, the USGS data that he was using was made available on AWS. They moved it into their own AWS accounts, and then they processed that data using resources from AWS. So that's what AWS is, right? It's storage, compute, networking, all of those sorts of things. So we work, I specifically work with geospatial agencies around the world, helping them figure out how to best use the cloud for their work. That includes generally public sector agencies that are making data available, but it also includes generally commercial sector customers that are looking to use that data, right? And so I get to see across the whole spectrum of data providers and data users. But I want to help frame some of the comments that I may give later, I want to go back to something I just said there, which is we're an infrastructure provider, right? Like, you won't really see us coming out strong for or against like any given standard. We're generally standards agnostic. You can make good choices and you can make poor choices, right? And you can use our infrastructure to go either way. But where we do have a part to play is through initiatives like the Public Dataset Program, where we work with customers to make high-value data available in the cloud. We look to promote and raise voices of groups that are doing this in the right way, right? And so when we see customers that are making high-value data available in good ways, then we can try and promote those. But if you're just somebody coming to the platform and trying to put things there, we're never going to say, no, you can only make this available as a data cube, right? Like, that's not the role that we play in this whole process. So this might come up in some of my comments later, so I just sort of want to let you know that that's, you won't hear us generally yelling for one thing versus the other. We're very open to whatever you want to do. We're just trying to promote best practices where we see them. So the other reason I'm here is because I also help support the Amazon Sustainability Data Initiative, which we'll actually be talking about a bit more later in this room. So in the next session in this room, we'll be back in here, and we'll be talking a bit more about that. But that is us trying to use Amazon's resources and the AWS platform to help groups working across the sustainability field use large amounts of data and large amounts of compute to figure out how to best meet their challenges. So some of that might come up as well. And I think that's probably about all I have, so I think well, I don't want to presume who's next, but thank you.
Who was next?
Just go down the line.
All right, we'll just go down the line. Thank you. So I don't have charts either, so I'm a little anti-PowerPoint today, which is good. So there's two things that come to my mind when I think of big data EO. It is analysis-ready data and data cubes. And many of you know those are two passions that I have. And within our CIOS community, there's a number of agencies that have been working very hard on the data cube. And you saw from Gilberto's presentation a bit of the technical details behind all that. I like to think that from my perspective, what I see when I see that working in the field and I see that working for some new users out there, like developing countries in Africa, that it really does provide a new tool set and a new capability that otherwise might not allow them to use the data. So it adds a bit of transparency so that they can see the data in operation, they can develop their own tool sets and the algorithms and share them among countries. And I believe that that is having a big impact in how we're doing capacity building and how we're seeing satellite data proliferate around the world. So it's bringing more users to the table. The second piece would be analysis-ready data. So this is something we had just started in the CIOS organization within the last year. And a number of the satellite agencies said, if we get the data and put it into simpler format, make it easier for the user. I don't know about you, but if you've had to deal with satellite data, I hate pre-processing satellite data. I just want it done for me, and I want it ready and able to use, and then I'll go forward. So I'm learning a little Python on the fly, which is all fun. So now I can take Open Data Cube and analysis-ready data, and even people like me can create some products and show people around the world how to use them. So in using the analysis-ready data, it's making it easy, very easy for these users to take advantage of it. I would think that probably a number of the people in the room have enough technical expertise that they don't necessarily have to worry about it because maybe they're generating their own. But I will say that there's millions of users out there that are just, we haven't yet connected with. So we have an opportunity through tools like the Open Data Cube, free and open tools and services and sharing of algorithms, along with analysis-ready data, to open up a whole new set of users. And we're seeing that with the projects in Africa, with the African Regional Data Cube, and now Digital Earth Africa, and I think there's a great potential to move this forward. Thanks.
Thank you, Brian. We were told we could have about 5 minutes worth of slides, and I represent the USGS Landsat team, and would like to begin with some slides, if you can pull them up. Okay. We thought these would be of interest to you because really this ARD concept, it started with Landsat. It started at our Eros data center. A fellow named Curtis Woodcock, Tom Loveland, and others 6 or 7 years ago. And we have some plans, and we are not standard agnostic. To the contrary, this is what this is all about. It's about data preparation, processing quality, and interoperability. And the USGS, of course, we have a science mission. We collect data, and we produce science that helps inform the way resource managers, disaster prevention specialists, and others respond to everything from hazards to water resource availability, ecosystems, and energy. And our land resources group is where we have the Landsat satellite ground system that we manage. We've got an office in every state, about 8,500 employees, and this is one of the most exciting things that is going on in the USGS, is what we're doing in terms of enabling resource managers and others around the world, decision makers, to use big data. And this is our vision. We call it Earth Map, and this is the grand challenge that the USGS and other communities are endeavoring to implement, enabled by cloud and AI and machine learning compute architectures. It will require a monumental lift across the communities, domestically and internationally, to accomplish the truly integrated science for predictive analytics that we envision. ARD and data harmonization are among the variety of remote sensing platforms integrated with in situ data and other sorts of inputs that are critical to these endeavors. And I've heard yesterday at the AOGO meeting and earlier today about the sustainability and how important it was, the Pacific community today. Well, Landsat, our sustainability goes back to the 1970s, 1972, and this historical record now was a one-off sort of thing to begin with, and now we have this sustainable land imaging vision shared with NASA that represents a long-term commitment to the Landsat science mission. Landsat 7 and 8 continue to operate today, and Landsat 7 is ending its life expectancy. We did the last maneuver for the inclination maneuver a couple of years ago. We don't have enough fuel to get through about April of next year. So April of 2021. So in 2020, by the end of 2020, we do hope to have Landsat 9 replace Landsat 7 to enable that 8-day refresh that we've been able to produce with the 2 operating satellites. And we're also now planning with NASA Landsat 9 and then Landsat 10, or Landsat Next, is also in the planning and aiming for a launch of Landsat 10, perhaps, by the mid-2020s. It is critical that the Landsat data is consistently processed through time and through both radiometrically and geometrically calibrating the images and defining what we call analysis-ready data. I'd like to give you this quick video that shows what our guys envision as what they're implementing to get this cleaner temporal stacking of data to support the time series analyses that Gilberto introduced to begin with. So, the way USARD works today, it's bundled as a GeoTIFF file that is compressed and zipped. Users have to download, unpack, and set it up. When we move to the cloud, they may not even want to or have to download any data. And as Gilberto said, that's the whole goal here. And we envision new tools for doing this on the cloud. USARD is generated for Landsat going back to the Landsat 4 mission. And at this time, ARD has not been produced for Landsats 1 through 5, but will be in the future. In the near future, we will be generating and distributing all Landsat ARD from the cloud, and this will enable users to more efficiently interact with the Landsat data and versus today's mode of downloading the TAR files. This is just an example of how we are eliminating using the cloud mask and other things that basically enable the user to go directly to the fun part, as was said earlier by several of the folks today. So as we migrate to the cloud, this will be completed through a validation process with Amazon Web Services about mid-2020. We're migrating to the cloud to take advantage of the greatly enhanced access to big data processing through our Collection 2, for example, as well as other new visualization functionality. This is the next big step in Landsat utility to the community. This cloud-optimized TIFF file sort of format enables tailoring access so that you can define the area of interest, whether it's a pixel or a polygon, and access just the data you need versus downloading an entire tile's worth. ARD is critical for the time series analyses that we find valuable. I'm a forest ecologist, and knowing this is just an example of how you can look at one pixel through time and how fire and disturbance change the reflectance, and then you can watch through time how that forest recovered. And this is enabled through this sort of time series analysis that Landsat brings to us. This graphic just shows how ARD greatly facilitates modeling of where and when and how landscapes are changing. This kind of modeling can occur for every pixel over all spectral bands using this what we call continuous change detection and classification methodology. And the journal citation is there at the bottom. And here is just an example of the kinds of projection scenarios that ARD can provide or support the development of in the future. In this example, this model responds to changing environmental conditions, aquifer depletion in Texas, and you can note how the irrigated cotton, the purple, can no longer be supported, and ag fields shift either to dryland wheat or revert to grass or shrub states. And this model here uses the IPCC's or WCRP RCP 8.5, and you can just look through time how we're using the Landsat archive fused with other sorts of information like climate models. So in summary, we believe that this effort to produce analysis-ready data provides a significant standard for land change analysis, and in the long term it will provide a significant capability to perform the analysis on the cloud. And the time series analyses hold tremendous potential for improving our understanding and understanding the interconnected Earth processes that will help us forecast future change And then Pete and the Aeros guides added this last bullet point here about the harmonization aspects, which have demonstrated a methodology that is currently available from NASA. And I've got the citation there, or I can give it to you later, that is being promoted by CEOS. And so as Australia picked it up and now CEOS, there's a great advantage to that standardization that we're providing through the Landsat archive. And I'll try to answer any questions that you may have. Thank you. Do you need this? Are you going to go up there? Or? Sorry.
Okay. Thank you so much. I have slides too. So I would like to talk a little bit about the Copernicus program, and I'm not sure what the slides come up, but independently from this, you know that the Copernicus program provides the Sentinel, provides the data free, full, and open. And that's not only the data from our suite of satellites, but we provide analysis-ready data, additional value products based from these satellites, from our contributing missions, which come from our international partners worldwide, and what is important, the in situ data. We have different areas of dedicated products in our services, which are the land service, the climate change service, marine monitoring service, emergency management service, the atmosphere service, and the security service. These are standardized products, visualization products, which can be used by everyone. And based on this, they are analysis-ready data, not as data, but as finalized products. These are developed regularly and made sure that they're enhanced based on the user requirements. Copernicus is a user-driven program, and that's a good thing to know in respect of analysis-ready data, because analysis-ready data is supposed to be user-driven, to make the data easy for the users. And that's what we want to do with the services, to have products available for people who do not use Python, who do not have the background. And I think the future will be to have something where you don't need to have just training to be used and to have as a tool to really tackle the societal problems that we have worldwide. So next slide is going to be, this is just for fun, to showcase where you get the data. And it's not only to get the data, but to get the products of the services. Based on the fact that we have free, full, and open data, we have a lot of data, more than 15 terabytes per day we produce. We're not able to disseminate it properly. So we're going to the cloud. We have 5 Copernicus DSs. These are data information access services where the data is available, but also to be combined with other data, which is cross-sectoral, which can be used by everyone, and to create dedicated products or analysis-ready data for specific sectors. So this is an open system where also interested parties can work on top of these platforms with their own data to make value-added products. What's the future? Of course, we will work with artificial intelligence to enhance the products we to make them even better in a variety of areas. As it says here, climate, agriculture, and marine environment, and so on. We try to use areas like multimedia imaging, where we have really a network of a big data space where you really can try to work on machine learning and to have enhanced training and have big training with big data. have to say that we cannot do everything at the same time, but we are working on training data sets to work on these artificial intelligence products in the future. And we have 2 projects working on this. So what I want to say, I think this is the last slide. What is important for the European Commission is we are very committed on working together with our international partners. We are supporting GEO, we are supporting CEOS, and during our last chairmanship for CEOS, we were really working with our international partners to work on analysis-ready data, but that's only the beginning. We really need to deepen our cooperation, to have descriptions for our data sets, to make the machine reading, to really try to make sure that the data sets are recognizable in each other's system. We will work with USGS and NASA in the future to work on future cooperation with the future Landsat and Sentinel systems together to make this analysis-ready data a reality. Thank you.
Thank you, Astrid, and other panel members for fantastic and brief presentations. Andrea's got us all well trained. I want to now frame two things. One, put everybody on notice that there is a Slido app, and if you've got Slido, it's 8172, as Dan said, and we are looking to that for questions from the audience. I'm going to run past you the generic question that we put to the panel beforehand, and then go back to them with some questions aligned with that. Then we're going to go to audience questions pulled from the Slido, and then we may have time for some audience participation, which will be mandatory. So the general question we framed this with was, what are the main future challenges for the Earth observation community to maintain continuity, access, distribution, standards, and interoperability of vast EO collections such as Copernicus and Landsat? And what are the actions that GEO can undertake now to help guide international ARD coordination into the future? So I'm just going to take slices of that question and put them to our panel members without having warned them beforehand. So I'm going to go first to the upstream end, which was Astrid and Virginia, who come from the organisations who've really pioneered global systematic observing, open licenses and free data that we're now all profiting from and enjoying. And our challenge now is, how are we going to handle all these massive data sets? And I guess I'd just like to invite Astrid or Virginia, once I give you the mic, to respond to the question of how well is the international coordination going to happen between USGS, NASA, Copernicus, and how mature is that when we're looking at, as Astrid said, 10 petabytes per year of new data from Copernicus, so pretty soon they must be pushing the 100 petabyte data stores. The need to reprocess those potentially as, thanks, man, as better algorithms arise. The need to have those, as Astrid pointed out, in environments where users can interact with both of them simultaneously, perhaps, and other data sets. So, Virginia or Astrid, can one of you volunteer to respond to that?
Oh, I'd love to answer that first one because that's easy. Yes.
And is there something GEO should be doing to help?
Okay. Yes, the collaboration between the EC and the U.S. and planning. When I first took over as just kind of a supervisor of Landsat and many other programs in our land resources area, I was pleased to go to my first Landsat science team meeting, and the EC was there in strength, in numbers, to coordinate Landsat and the Copernicus plans for the future, and everything from UTM versus Albers and all that discussion was going on. So I think that the answer is through the CEOS is probably the greatest hope for this harmonization and to establishing standards for interoperability. So that's what I would say is the answer to that question. It is the coordination. And I think right now we're focusing on land, but in the future there will be a shift to atmosphere and ocean. So starting off with the land and then continuing on this whole theme and this interoperability that we're working on with CIOS. So I'd say the CARD 4L is the greatest hope for that interoperability, not just of Copernicus and Landsat, but for other data streams.
Yeah, I have actually nothing to add because you just said it very well. We work very closely together. If you're interested, look at Card4L on the web. There it's really shown where how we coordinate this, and we're going to expand this, go away from or expand it from land to other areas like ocean and atmosphere. Should I answer the others?
No, I'm coordinating this. You behave. I would like to, thanks Astrid and Virginia. I would like to actually go to Joe as a data hoster and pick up on a question that George from the audience very sensibly put forward, which is around the commercial models for cloud hosting of data. Amazon is stepping up in magnificent ways, and I'm aware of that because of my work in Africa. But how commercially driven are these interests of the cloud providers in hosting these data? And is that commercial model mature enough for us to rely on the goodwill of going forward? Are there things that still need to be resolved? How mature is the thinking of the cloud providers in this space?
Yeah, so I think, I mean, I can only speak for us in this space, but we're very driven by our users, right? So if we see a large number of users trying to access this data, it obviously becomes commercially interesting, right? But part of your question there was, should you depend on the goodwill of groups to do this? And I think the answer is very definitely no, right? Like, no. I mean, there are very specific reasons why we might do it. And a lot of times those come with agreements, so it's not like things would just disappear tomorrow. But if you're taking advantage or depending on the goodwill of a commercial entity to do something, you run the risk that when it's of no more commercial interest, then they won't be willing to do it anymore, right? And you will also only see them look to make available data that is of commercial interest. There's a whole lot of data that's useful in a lot of ways that aren't necessarily commercially viable, right? And it doesn't mean it shouldn't be used or made available. So that's why I think we see a mix of, I mean, the most interesting thing commercially is if an agency says, like, here's the data we want to make available, and we will use your service and pay to do so. Like, that is the most stable relationship, and that's a relationship that we see with a number of geospatial agencies around the world, right? I think cloud was mentioned in a number of the different presentations here today. Some of that's on us, some of that's on other clouds, and that's fine, but those are the most stable relationships, right? So, like, I think there's always a way, and I mean, we do this with the public data set program, that there's always a way in which that will work for companies. But if you're a government agency and you have requirements to make data available, you shouldn't be dependent on the goodwill of any commercial entity to sort of be meeting those requirements. Like, I don't think that would pass muster if you had to go before Congress and say, like, yes, we're making all our data available. They're just being really nice and giving it to us, giving us the storage for free. Yeah, I think there's definitely commercial interest here. For our purposes, we use a lot of the sort of the thing that we do through the public data set program to experiment with better ways, right? Like, we can do that at scale. When we made over 1 petabyte of Landsat data available, we made it available in a different way that's now turned out to be cloud optimized GeoTIFF, right? Which you're all able to take, and like, we were able to help work with customers and show the value of that. And that is turning into a way that USGS is making their data available going forward. And I think, like, that's super valuable, right? Like, I don't know that USGS would have been able to just experiment with making petabytes of data available in an unproven format right away. And so that's somewhere where we were able to help out. And that's commercially of interest to us because it brings more users to the data, right? So.
Thank you.
Yes, we pay for this too. I mean, it's not like a goodwill gesture. It's a contract we have with these guys, and you may not get it the next time we competed. I don't know how that would work, but it is something that you just can't depend upon someone to do out of the goodwill of a commercial sector to do forever. Yeah. And so through the Sustainable Land Imaging Program, we are committed on the long haul, and we'll pay for it.
Yeah, and so I think just to close out the thought about commercial piece, since you just said you're paying for it, I can say you're paying for it. The initial Landsat data that was made available in AWS did not come directly from USGS. It actually came through a US-based startup called Planet Labs. And then that we did at our own expense. Right? Planet did some work, we did some work, and now it has turned into like a commercial contract that USGS is paying for. And so that's the commercial model, right? Like we do some work up front with people to prove the viability, and then it turns into a long-term commercial contract.
So there are solid commercial models. There's some great innovation happening. We shouldn't expect charity. I'd like to go to, and thank Virginia for saying, I don't know what happens then. Where if there's a contract, what happens when maybe USGS, Amazon doesn't win the next contract? Does it go to a different cloud provider? Is that a serious, I guess in your mind, Virginia, is that a serious bump in the road or a massive rail gauge problem? Or are we mature enough to manage that?
No, I don't think it's a problem because the specifications for the existing contract would allow for that transition, just following U.S. law. For competition, we have to build that into the current contract so that we're not, depending upon them for code that we don't have access to. So it'll all be ours that we can transition to another contract at some point if that were necessary in a competitive landscape in the United States.
So before we leave that question, I want to give Brian an opportunity to make any observations, as Brian's passionate about using the data, about working with users with the data. And so I'd like to just give you the general question, Brian. What do you see as the future challenges for the EO community in this space, and what's your experience so far?
So if I look to my right and the data providers create the analysis-ready data, put it into the formats that we need, data aggregators, whether they're paid or do it for free, most likely get paid. They end up aggregating that data and putting it into cloud environments that we can use. I believe the challenge for the future is if this data exists on multiple cloud frameworks around the world, how do we connect it all? How do we make use of it together? If I want some data that's sitting on Google, which they host it a lot for free at time being, but let's say I want to use their framework for cloud. I want to use Amazon's cloud framework for another data set, and I want to go to Diaz for another data set. How can I do that efficiently? And that, I believe, is where the real challenge comes in. How do we connect this? How do we optimize the cost of doing that and the complexity of doing that? Because that's going to give us a lot more opportunity. We can then get to in situ data. We can get to atmospheric, land, and ocean data and pull all these things together. Right now, I believe it's pretty disparate. It's in a lot of different formats and in a lot of different frameworks. But as time progresses, I think we're heading closer and closer to cloud frameworks that look very similar, analysis-ready data frameworks that look similar, and that's going to add a lot of capability for us to bring this data together.
Well, thank you all. I think we've covered some really great ground there. We've now got time to do two things. One is to go to some of the Slido questions, and the other is to invite other questions from members of the audience who may not be Slido adept or may just have new questions. I'm not sure if Dan wants to take over at this point, but I'll kick on for the first one. I think we've done the first question, and you can take that offline with the speakers. Let's go then to the... So let's do alternate. I'd like to just see if there's anybody in the audience who has a question at this point they'd like to raise. Okay, if we've got no takers from there, then I'm going to let Dan handle this one.
So we've talked a little bit about producing data sets and storing data sets, and a big part that's missing is sort of processing those data sets to generate useful products that can be leveraged to make decisions, right? And Gilberto talked in his opening slides around lots of the different organizations and groups that are working to provide tools in that space. And fragmented was the phrase that was used. So I guess maybe just going to Brian first to get a point of view from the role that you're playing through CEOS in the Open Data Cube, Do you see that as an issue, and are you doing much to work with these other kind of groups and entities in that space?
Yeah, you know, if I thought Open Data Cube was the only solution, I might be worried. I believe that we're in an era now where technology is progressing so rapidly and it's changing so quickly that I really think 5 or 10 years from now, I doubt that Open Data Cube is going to be the answer. It's likely going to be something new and innovative and different. But if we're part of that process and we're pushing the limitations, we're opening people's minds up to new technologies and how we interact with this data, we're really pushing hard for the data being open and the algorithms being open and the whole scheme being transparent. To me, that's the ultimate goal. Whether it's called Open Data Cube or what that technology looks like, I don't think matters so much. So, you know, the charts that Gilberto had up there were very interesting because truly it is a fragmented group of initiatives happening right now and a lot of technologies being played with. And maybe a few of those will emerge to be acceptable across all the entities, but I'm not that worried about it. I think that it'll just evolve with time, and who knows what the next technology will be, but we'll make sure the data fits whatever it is.
So that's the joke.
Yeah, I just wanted to add. I mean, I think there's obviously an inherent confusion if there are a whole bunch of tools that are out there to work with the data. But I imagine you would find people that prefer to use any given slide or any given tool that Gilberto had up on that slide, right? Like they all exist for some reason. And I think that's good, right? Like I think there should always be a space for individual tools that meet a very, very specific need to exist. Except for the fact that it creates a lot of confusion. But I think standardization, I think Brian was just sort of getting this, standardization in some format, or even just like 90% of the data sets that you want to work with are in 2 or 3 different formats, depending on whether they're vector, raster, tabular data, right? That, I think, would go towards cutting out so much of the overhead with working with these data, right? And then the probably negative downside is that you would probably see even more tools then, right? Because it'd be easier to work on top of these data sets. But I don't think that's a bad thing, right? I think I would rather see more standardization on the bottom layer and then a whole bunch more things show up at the top layer that meet very specific demands for groups.
I've got one more question.
And as long as the communication and we've got the groups like the CIOS working together, then I'm not worried about it either. Just 3 years ago, we were talking about ARD for the United States. We didn't even think we could do Alaska very quickly. And now we're talking about opening up the whole archive, collection to March 2020. And so it's evolving so rapidly. So again, the standardization, that's what we're looking to CIOS for. And as long as the standardization progresses with the technology, I'm not really worried about it. I think it'll happen.
And I would like to add another angle which was not really discussed here, and because it's very data-driven. But big data also relies on the users, on the people who use the big data. And I think especially for CIOS, we have the CAPT group working on capacity building and data democracy. When I talk to people working on the Copernicus data, they ask, how do we use the data? So I think one of the challenges is the younger generation to create the skills needed to really work on these data sets and really work on the standardization, on the interoperability, on the getting the network cloud environment. It's not always all the people with a PhD or a master in computer science. We need to get a specific training for people to really ask the right question and do the translation from what is the challenge towards what do I need to put into the big computer system to get out what I need. And I think that has not been addressed so far in a global environment, how to get these kind of things coordinated together with the coordination we're doing with the data. Because the data coordination is the important thing, but we need also to have a network of people doing this. For example, for Copernicus, we have now global network, or we're building a global network of Copernicus academies to start working on this. So thank you.
Okay, thank you. A follow-on question to that, acknowledging the openness of communication and collaboration that needs to exist between all the different actors here. There's a question from Alex here around the fact that the USGS is moving towards cloud-optimized geotiffs, and wondering if Copernicus intends to follow. But I'd like to frame that a little bit more generally and asking, how open are the data providers to responding to these kinds of user requirements around the way in which the data is consumed?
Copernicus is a user-driven program. If the users want to have faster data or data in a different way, we will respond to that. Of course, with the DIAS will be on the cloud environment. The data will be made be in the cloud environment, and we will work with the partners to make it even more accessible. Yes. Just to let everybody know concerning the question from George, what is the status of the Copernicus DIAS platforms and when it will be open for business? They are all open for business. Just, they're also here at the Geo plenary.
There was also a question, I've just lost my Slido and it's dropped off there, about planets. And I want to make an observation that we did invite Planet to be here. We hoped they would be here because they're doing some very exciting stuff as a data provider. I could make my own observations, but I'd rather not do that. I just wonder if someone else in the audience would like to, and the question was, can we see it? Okay, I'm going to try and find it. The biggest small company in EO isn't here, Planet. How are their innovations, aside from COGS, filtering up to the national satellite operators? Just wonder, Brian, were you at the ARD19 convention? You weren't. Is there anybody who would like to comment on this? As I said, we did hope that Planet would be here to participate on the panel, but they're not. I can say what I've observed is that they are very actively calibrating their data to be consistent with the ARD standards that CEOS is putting out, and they are then generating dense time series at high resolution that are consistent with the foundations being laid by Sentinel and Landsat. Beyond that, I don't think we've got anybody to comment.
Yeah, so I think another piece here is the STAC work. So STAC was on Gilberto's slide, Spatio-Temporal Asset Catalog. This is partially, Planet should take some credit for this as well, because this has been, Chris Holmes has been leading a lot of that, and he's been mostly doing it, I think, with his, he's a fellow at, or he was when he was doing this, I think he still is, but Radiant Earth Foundation, and I think they've sort of been taking ownership of this, but he's also at Planet, and I think this, it's another metadata standard. It's very lightweight by design, and it's specifically for trying to sort of do like discoverability, searchability, web indexability, if that's a word. It's not supposed to replace other larger metadata standards, but there's a number of geospatial groups that are sort of taking a look at this and adopting this for some of their data distribution, and Planet being one of them. But also, like, to their credit, and I will tell you, like, people were asking me, oh, like USGS is putting their data on AWS, like that's great, it is great. And I was like, yeah, they're going with COGS, like that's great. And they're like, oh, are they going to use stack metadata? And I said, no way, like it's just too quick, like they won't do this. It's a totally unproven spec, right? I don't even think, it's not even reached 1.0 yet. But I was wrong. They're making stack metadata available for all their data, which is fantastic. But I think that to me is one of the areas where Planet, through Chris Holmes, is sort of leading the way in another sort of major thing that I think a lot of companies are taking advantage of.
Thanks, Joe. That's a great pickup there. And there is clearly this incredibly rich dialogue happening between companies like Planet and USGS and others at a technical level. I guess we have got another question here from Chris, which is about who in your minds are the biggest users of the data? Are these researchers, decision makers, or some other group? So I guess I'll throw that quickly to the panel. And then I want to come back to the panel and say, so what's the role of Geo in all this? So Firstly, who are the biggest users? We've heard a lot about users. When I hear Planet doing work like this, I think of them as users, for example, of other people's data. I suspect that's not the way the European Commission see it. So it'd be interesting to get some views on that.
Yeah, I think broadly I would just say, I think the answer is going to be different for each of us because we interact most heavily with different communities, right? So I definitely see a lot of commercial entities being the largest users of the data. But it'll be very interesting to see what happens with collection 2, because I was just at Pecora recently out in the US, and somebody said something, and I mean, it's obvious if you think about it for more than 30 seconds, and I guess I just hadn't. It always occurred to me that USGS would need to process, it always occurred to me that the group responsible for the Landsat data would have to reprocess all that data, right? So that's petabytes, 8 petabytes-ish of data that they'll need to reprocess. Somebody told me, this is somebody on LCMAP, and they're like, we will also need to reprocess all of that data for their own purposes. And that was like, I was like, oh my gosh, I never thought about that. All of the groups internally who are using the full archive will also need to reprocess the whole archive, right, if they want. And so I think the government agencies themselves are also some of the largest users of that data, right? So, but I think it'll depend on who we talk to on a regular basis.
Go on.
Users.
Great. So yeah, I think it's researchers, yes, but many decision makers, governments, local and regional users, associations using the data, and more companies are using the data from the Copernicus platforms.
I think the #1 downloader of Landsat data is Google. So, and then if you could keep track of what happens to it after Google gets it. But then nations, certain large nations account for it, and researchers. But more and more, I think we're going to see resource agencies that actually manage the land surface. Hopefully we'll be able to use especially when we go to the cloud and they don't have to download and they can use the tools that we provide. I think that's kind of the vision that we have coming from the USGS, serving the resource managers of our nation.
So could I follow up on that question and then ask, do you think the mechanisms are mature for those diverse user communities in a new world to communicate back to the agencies in terms of whether the data are ready and so forth? Right, and we have this wonderful Landsat science team that NASA is primary sponsor for in USGS, and they give us feedback very just unabashedly, what their perspectives on what needs to be done. I think about the Southeast Forest Cooperative and what their demands are. So we have kind of a built-in user group it's the Landsat science team that actually we fund folks to try the data and to help us refine the approaches for the future collections, for example. And I'm aware Copernicus have a major
There's one thing I had on my mind, and it had to do with what is the largest growing set of users. And I might think that that's the non-traditional users out there and the ones that have not been using satellite data in the last 5 or 10 years. If you think about the populations in Africa and the populations in Asia, and all of this data now becoming available to them through cloud and computing frameworks, that to me is a huge growing potential. So it'll be really curious to see when Digital Earth Africa gets up and running within the next year, the number of users that will be in country there, both researchers to farmer levels, whatever it might be, will that cause a whole new increase in our user base? And will that also happen in other parts of the world where there's high populations?
So I think I'd like now to come to the second part of the question, which is what's the role for GEO in this? So what we've heard is that groups like CEOS, which is a space arm of GEO, if you like, has established CEOS analysis ready for data for land, the specifications around analysis ready data. There are bilateral communication mechanisms for coordination. Potentially there are multilateral forums through CEOS. There's work happening in the private sector, which is bleeding into the government sector. But there is a very big picture going forward, of hundreds of terabytes of data being produced and needing to be coordinated on a global frame, similarly as the, say, meteorological data might be. That's the picture in my mind, and I'm interested in whether there are strong views from the panel or from GEO Secretariat about what the role of GEO might be going forward. And I guess I'd like to give Gilberto an opportunity to say something at this point, if he wishes.
So I think the role of GEO is keeping things in checks, in sanity. Sanity in the following sense. We have, what are we? What is GEO? It's an intergovernmental organization. So we have member states and institutions in member states. And the overarching vision is that Earth observations can be a force for the good. And the force for the good is well, the biggest force for the good in the world is empowering women to start with. And the second biggest force in the globe is empowering institutions. And I think that both, of course, public and commercial, but in the member states. So the general sense in GEO is that we need to serve the member states. And serving the member states, meaning to identify which opportunities are there to broaden the use of Earth observation there. Not, and I've been telling that there are people in the community searching for unicorns. Let's understand. At the unicorn, meaning that mythical user that will be happy with pushing a button and getting a response. I don't think this exists. What I think exists is that the need for member state institutions to get to grips with big data. And this means we cannot dump down the problem. What is dumping down the problem? Assuming there will be one size fits all, that one service can serve the whole globe, that you can have something done in one place on Earth that resolves the problem of everybody. And the other thing is empowerment. In one hand, we recognize that we have petabytes of data. These petabytes of data challenge us in a way never seen before. And the challenge is for intelligence. And in that sense, I'm very critical of not the commercial cloud providers, which I'm very grateful, but the commercial. I have not seen in the last 20 years any major innovation in remote sensing and Earth observation coming from the commercial sector, from the point of view of data analysis. We have seen innovations coming, for example, from Planet, but not the innovations from analysis. All the innovations from analysis have come from the researchers. So I very much believe that GEO is pushing the envelope and saying, we need open source. We need to put things in open source. We need to make a community shared. We need open science. So GEO is very much pushing for empowerment of institutions globally for open science. That's what I think the mission of an intergovernmental organization. And keeping things in sanity. Please don't believe that you're going to have to develop a system that serves everybody. Don't do it, please. Use that money wisely. Don't fool yourself searching for unicorns. They don't exist. Empower the institutions. Empower the globe. Make them available. Digital Earth Africa is a very good example of such an initiative. So we're looking for open source empowerment of qualified people. Don't think that any user will ever do it. So the famous joke I have, which is not a joke, it's true, there are very many people on Earth that believe in the Pope Francis. Now, you might be one of them or not, but certainly there are millions of Catholics. There are very few people on Earth who Pope Francis believes in them. I'm one of them. Because when Pope Francis says the Amazon is burning, He believes in the data that my institution in Brazil is publishing. So how did this institution in Brazil get to produce the data, the fires in the Amazon, that the Pope believes? We need to understand this better. It was an empowerment. The Pope would have more restraint if only NASA produced that. NASA produces that data as well, but the fact that an institution on a country which is suffering from serious problems on deforestation is able to provide accurate information that the Pope believes, Macron believes, Merkel believes. Bolsonaro said he doesn't believe, but he believes. So why do you get to this point? Is empowerment. So it's not as strong as women empowerment, but empowerment of institutions in the third world is the goal of GEO. That's how we're going to make those world better.
Thank you, Gilberto. So now we've got 5 minutes to go to closing comments or any last interventions that the audience might want to make. You have been very quiet. I'm tempted, but I'm not going to randomly attack you. So I'll throw back to the panel for any closing comments. Who would like to go first?
I just wanted to add one other thing I had on my little notes here about what I think GEO can do, is not to forget to advocate for free and open data, that we've come a long way with this lots of data sets to my right now being open and freely available to all of us. And we need to continue to push that. There's so many more missions coming. If you look at the CIOS mission hockey stick in the future, it just goes up and up. So a tremendous number of missions being launched. We need to make sure that many of those are open data and analysis-ready data so that we can use it. That is something we have to continue to advocate for and show the value of what it's given us.
May I add, just in my closing remark, just to support what GEO's role would be, and you touched on it, Gilberto, but the capacity building, that foundational task that GEO has been given. At the AmeriGeo meeting in Peru in August, the number of people that came, the young people, like you were saying, to attend the training sessions, so using GEO, and especially these regional GEOs now, to step out and develop this capacity, beginning with the young people. It was just amazing. We had standing room only in the SRTM training, and it was just, it just was a hint of what is possible to me. And anyway,
Yes,
you probably feel the same way.
Yes, I also want to advocate, even it's boring, free, full, and open data policy is the basis of what we talk in the future, and all the other missions worldwide should be clearly free, full, and openly available, and they have the exchange of data flowing from one place to another. That will be the great future needed for to have a global vision of this planet and to tackle the challenges we face.
Yeah, so I think my closing remark will maybe just be what I was going to use as the answer to what can GEO do. And I think Gilberto already said it, but from my perspective, it's acting as a aggregating and mobilizing force. We have the joint GEO and AWS Cloud Credits Initiative, and there's 21 or 22 organizations from low to middle income countries that are receiving resources and training to be able to take advantage of pretty much everything that we've been talking about. And that's made possible in large part due to all the groundwork that GEO has already laid over these years. So they keep doing that, right? I think that's very good. And just as a shameless plug, we will be hearing from 4 of those groups in this room in like 30 minutes. So if anyone would like to stay and see that, you'll hear more about that and hear from some of those groups.
So there's a hand.
Pretty good, but
yeah, look, I'm just looking at what you guys have done even in this industry. It's absolutely fascinating and it's incredible, right? But I'm just wondering, where does all this fit into from a defence, and how is GEO working with the defence industry as a whole. Because some of the stuff here, and I'm sure some of you in here have seen some of the technology here, is in the defence side is many, many years ahead of time. When that gets proliferated to the commercial users, that's going to open up an incredible opportunity, but it's also going to cause some of these sort of fragments, I guess, if you like, these parameters are going to be disrupted. So one of the questions is how particularly also from a understanding what kind of image formats we should be working on, cloud storage, data dissemination. Have you guys started thinking about that? Because in the next 4 or 5 years, that's going to come out of, some of that stuff's going to come out of declassification, and it's going to have fantastic implications, particularly for the developing nations. I mean, I see that every day from my line of work. I'd love to hear what you guys think.
Anybody going to tackle that?
I mentioned it a bit earlier, you know, in the case of Open Data Cube, I doubt it's going to be precisely what we're doing in 5 years from now because the technology is changing so rapidly. So I do anticipate changes like this and things coming to us from the, you know, the black world and the defense world. And so it's exciting to see that some of that might come our way and make everything we do with satellite data more efficient and better. So we welcome that. We'll see what happens. Maybe some of the data too. That would be great. Open that up. Yeah, well, you know. Well, if it's old, you don't need it anymore. So.
Okay, marvellous. With the time in mind, I think I'm going to bring things to a close. A few last comments from me. We should be celebrating the successes that we've had already. We've come a very long way, and that's really exciting to see. We need to continue that momentum to face some of these challenges in the future, and clearly working together and collaborating across communities is the right way to do that, and so more of that is a really good thing. And then finally, let's not forget that all of this is being driven by these different user groups and the capacity building that comes along with it to really drive the adoption of these technologies into the future. So with that in mind, if you could join me in thanking everyone that's contributed to the session this afternoon.